Hey there, students. Today we're going to look at simplifying, multiplying, and dividing rational expressions. And so we're just going to jump straight into it with the definition of a rational expression. A rational expression is the quotient or ratio of two polynomials. We're going to start off with four examples. X squared minus 4 over x squared plus 4x plus 4. We've got 12 over 6x minus 24. We have 7x plus 21 over 35. And lastly, 9x over 6x squared. All of these are quotients of polynomials, or fractions where the numerator and denominator both consist of polynomials. Some of these are monomials, and some of them are even constants, but all of those still fall under the category of polynomials. Rational expressions like these come up in various situations. For example, children and appropriate drug dosages, inventory costs for a business, the costs for an environmental cleanup, etc. And there's a lot of things that we can do with rational expressions. Right now, though, I just want to focus on simplifying them. When we looked at other expressions, like fractions or exponential expressions, we wanted to be able to simplify them because that made our lives easier. And the same thing is true when we deal with rational expressions. Now, to reduce or simplify a rational expression, we're effectively going to do the same thing we did with reducing fractions. We looked for factors in the numerator and denominator that they had in common that could be canceled. And the same thing is going to be true here. But when we're looking for factors of polynomials, we're going to have to, you guess it, factor them. So let's look at these one at a time. Let's simplify x squared minus 4 over x squared plus 4x plus 4. This is a fraction. Certainly it's more complicated than the fractions we saw earlier because there's polynomials in the numerator and denominator. But to simplify a fraction, we need to find any common factors that the top and bottom have. And to do that, we're going to have to factor each of these polynomials. If we start with x squared minus 4, we know that that's a difference of squares. We can factor that as x plus 2 times x minus 2. In the denominator, this is a trinomial. We can use unfoiling here. We're looking for two numbers that have a product of 4 and a sum of 4. And those numbers are 2 and 2. So this becomes x plus 2 times x plus 2. And now that we've factored, we can see that the top and bottom both contain a factor of x plus 2 that can be canceled. And when we cancel that out, we're left with x minus 2 over x plus 2. And this is our final answer. Now, I always have students who see these problems and they ask, can't we also cancel the x's in the top and bottom? Or even in the beginning, can't we cancel out the x squareds? And it's really important for you to understand why we can't do that. The reason we were allowed to cancel out the x plus 2's here is because they were factors. They were things that were being multiplied by other things in the numerator and denominator. And we can get rid of them because undoing multiplication is dividing. So we're effectively dividing the top and bottom by x plus 2. That's what we're doing when we're canceling. However, if we wanted to get rid of these x squareds, for example, these aren't factors that are being multiplied by other things. These are terms that get added to the rest. If we wanted to just get rid of these x squareds, we would effectively be subtracting x squared from the top and bottom. Are we allowed to subtract the same quantity in the top and bottom of a fraction? No, we're not. The rules said that we can divide the top and bottom of a fraction by the same number. So we can't get rid of these x squareds, and similarly, we can't get rid of the x's, we can't get rid of the 2's. The only time that we can cancel something in a fraction or in a rational expression is when the numerator and denominator are factored and there's a common factor that we can pull out. That's what we're going to be doing in each of these problems. So if you thought that we were done with factoring after the last lesson and you breathed a sigh of relief, unfortunately, that is not the case. We are going to be factoring a lot moving forward. Let's take a look at these other examples, and then we can move on to multiplying and dividing rational expressions. The next one we have here is 12 over 6x minus 24. Now, the numerator is just a number. We could factor 12. It's 6 times 2. It's 3 times 4. But we're going to leave it alone just for now, because what's more important is that we factor out the polynomial in the denominator. Now, 6x minus 24 has a GCF that we can pull out. That GCF is 6. So we pull out 6, and we're left with x minus 4 in parentheses. And now we can find a factor that we can cancel in the top and bottom. If you look at that 12 and the 6, both of those are divisible by 6. So we can reduce them by 6. That leaves us with 2 in the top and 1 in the bottom. Now we're left with just 2 in the numerator. And the denominator, anything times 1 is itself. So we're just going to leave x minus 4 in the denominator. And this is the simplified answer. There's no more factors in the top and bottom that we can cancel. So we're left with 2 over x minus 4. Let's look at the next example. 7x plus 21 over 35. Here, the numerator can be factored because there's a GCF that can be pulled out. If we pull out 7 up top, that leaves us with x plus 3 as our leftovers. And we've got 35 in the bottom. Now, there is one factor that the top and bottom have in common that can be pulled out. That factor is 7. So if we reduce 7 and 35 by a factor of 7, we're left with 1 up top and 5 in the bottom. So our denominator is just 5, and the numerator, 1 times x plus 3, is just x plus 3. And we're left with x plus 3 over 5. I want you to notice that all of these final answers are much simpler than the original expressions we start with. We've got much smaller coefficients. We've got sometimes even smaller polynomials with fewer terms and smaller degrees. We are ending up with things that are simpler than we started with. We've got one more example here, 9x over 6x squared. This one doesn't have any factoring that needs to be done because these are both monomials. In fact, this is something that we've already seen before. We can just simplify this. We can reduce 9/6 to 3/2, and we can cancel one of the x's in the numerator and the denominator, and that leaves us with just a single x down below. And so we end up with 3 over 2x. In the next video, we're going to look at multiplying and dividing rational expressions, which is going to involve more factoring and more reducing. But we wanted to do these first just to get the basics down.